So this is the next unit for this semester. It's called Polygons and Quadrilaterals. And we'll begin with the idea of a polygon. What is a polygon? It's what you say when your parrot flies away. Get it? Polly, want to correct? Okay, all right. Anyway, a polygon is a planar figure, right? A two-dimensional figure only, formed by 3 line segments or 4 line segments, 3 or more, and we call those segments sides. And I know you guys have played with polygons before. You probably are familiar with a triangle, I hope, finishing the triangle unit, and even some quadrilaterals. You probably recognize the Pentagon name, hexagon. You might not recognize the next one. Would you like to guess how many sides this one has? Heptagon has 7, octagon has 8, nonagon has 9, decagon has 10. So on this note sheet, we're going to write in those number of sides. Part of this unit is being able to name polygons by their appropriate name. These are the names you should memorize. There are also names for greater numbers of figures like undecagon and dodecagon, tridecagon. And I'm not going to hold you accountable for anything above a decagon. Okay. If you're interested, I do have a cool little worksheet that would take you through how to name like a 568gon. It would be a pentaconta, hexa, hepta, chi, octagon. So there's a cool naming convention that's kind of fun to get into, and I'll show you that if you're interested. But again, all you're responsible for is knowing these names through 10. And then for anything above that, we just put the number of sides, like a 15 gone, 21 gone, 48 gone. And then you know it's a polygon with that many sides. We can generalize polygons as having n sides, in which case it has n sides. Now, what we've been working on in this last unit is triangles. And in triangles, we learned about the triangle angle sum theorem, saying that all the angles in a triangle add up to 180. Is that also true in a quadrilateral? Do you believe that the angles in a quadrilateral add up to 180?
Yes.
What's a familiar quadrilateral that sort of looks like? Square. And do you know what the interior angles are in a square? 90 degrees. 90 times 4 is not 180, is it? It's 360. So what we're going to do is we're going to look at ways that we can calculate the interior angles within a polygon. And the way we'll do it is we'll cut it up into triangles. If I sliced right through here, what would be the sum of the degrees inside this triangle? And then there's another triangle over here that's also 180. And I don't know how these split per se, but the combination of this little piece, this big angle, this little piece, and this big angle all together would add up to 360. Because with a 4-sided figure, I can make 2 triangles. Each one is 180, which means the total number of degrees inside that shape is 360. I can do the same idea with a pentagon. If I were to take one corner, one vertex, and create triangles from that, I create 1, 2, 3 distinct triangles, which means the sum of the interior angles in a pentagon is 180 times 3, or 540. If I do it from one particular vertex in a hexagon, I can create 1, 2, 3, 4 triangles, which means the sum of the interior angles of a hexagon is 4 times 180, or 720. I'm going to leave these for you to fill out, but let's jump to the end, the n-gon. If an n-gon has n sides, how many triangles can I draw on it? Look back up here, see if you can see a pattern to go from the number of sides to the number of triangles. Marshall? N minus 2, excellent. It's always 2 fewer. So if this is 7, we know this is going to be 5. If this is n, this is going to be n minus 2. And if it's n minus 2 triangles, what's the sum of the interior angles? It's going to be the 180 degrees for each triangle times n minus 2, which is the number of triangles. And this is our formula for S, the sum of the interior angles. It's equal to n minus 2 times 180 degrees. So if we come down to number 1 here, it's asking us to find the sum of the measures of the interior angles in a 15-gon. Okay, so for this, my n is equal to 15, which means my sum will be not n minus 2, but 15 minus 2 times 180, which is 13 times 180, which is 2340, 2,340 total degrees inside a 15-gon. Would you guys please do the 21-gon? Figure out the sum of the interior angles. All right, so for this one, we get an n of 21, which means our sum is going to be 21 minus 2 times 180. So 19 times 180, which gives us 3,420 degrees. Any questions on this? 5, I think I've already memorized that formula. It makes sense to me. I can find the sum of the interior angles in any polygon. 3, if I'm looking at the notes, I'm sure I can do this. I'll get there. 1, this is confusing to me. Great. Second piece, how do we apply this? Let's look at number 14. So we're skipping 12 and 13 for a second. The instructions say simply solve for x. How might we accomplish this? Money? Okay, I like that idea, but if I broke this into triangles, the 110 would get separated. And I don't know if it's like by 20 and 90 or 70 and 40. Liana? Excellent. So it's 2 steps. Step 1 is we say, what's the number of sides? 1, 2, 3, 4, 5, 6. It's 6. Since it's a 6-sided figure, a hexagon, I can use my formula. The sum is going to be 6 minus 2 times 180, which is 4 times 180, which is 720 degrees. So all these angles together add up to 720, which means if I add them all up together, 110 plus 8x minus 1 plus 5x plus 36 plus 116 plus 7x plus 19 plus 6x minus 2 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All 6 of them equals how much? That same 720. And then I just need to combine all the like terms. When I add up all the constants, I get 278. When I add up all the x's, I get 26x. Together, those should equal 720. I'll subtract 278 from both sides, and I get 26x equals 442. Divide by 26, divide by 26, and I get that x is equal to 17. Any questions on doing these types of problems? 2 steps. First step is figure out the total. Second step is do the sum equal to that total. Last piece of instruction today is a specialty item. This is a little bit counterintuitive. If you were to know that regular polygons are different than non-regular polygons, which one would you guess is the regular triangle? How would you classify a regular triangle? Regular to me sounds like not special. But in fact, in the world of polygons, regular means very special. It means both equiangular and equilateral. So which quadrilateral is the regular quadrilateral? Is it a parallelogram? Is it a trapezoid? Is it a kite? Is it a square? Is it a rhombus? Which one of those is both equiangular and equilateral? Square. So I can take, for instance, 5 sides here and make a little house looking thing. And do we agree that that is a pentagon? 5 sides, so it's a pentagon. And all these angles are still going to add up to what we figured before. 5 minus 2 is 3 times 1/8 is 540. But this is not a regular pentagon because the angles and sides are different lengths. There does exist a pentagon. This is my effort at drawing it. It's probably not perfect, but where all the sides are the same and all the angles are the same. This one's not a regular pentagon, this one is. The question is, how big is one angle in a regular pentagon? Well, if we know that a single angle in a regular pentagon is the same as all the others, then we can take the equation for a sum and just divide it by the number of sides, because that's the same number of angles. Single interior angle in a regular n-gon. A regular n-gon is n minus 2 times 180. So that formula for the sum, but now we just divide it by n. So for a regular pentagon, we'd identify that n is equal to 5. And we'd say the measure is 5 minus 2 times 180 over 5, which means 3 times 180 over 5, which is 540 over 5, which is 108 degrees. That's the size of one angle in a regular pentagon. Okay, so we're now going to move into the algebra skills survey. Please clear your desks, no calculators, don't have this sheet of paper out. But when you finish it, you'll come bring the test up to me, and then you can finish this worksheet. Just take everything off your desk so you're not tempted to look at something you're not supposed to. Put that away, please, Tristan. Thanks. Put your phone away too, thank you.